So we are going to discuss about the energy density in the capacitance. So we are considering the small cube, that is the it's have the side of del D. Okay, we are considering a small portion in the parallel plate, that is actual parallel plate, that was the total capacitance. We are finding the energy density in the smaller portion, that is the del D. Okay, it's have the side del D. Okay, so here we are considering the cube, all the sides are equal. Okay, so that was the actual capacitance. So here we are finding the energy density. So that is the del C, that is the capacitance in the small portion. So here we are consider the small portion, that is the distance is the del D. So in the small portion it's have the capacitance that is also small, that is the C equal to epsilon A by D, actual formula, that is the C equal to epsilon A by D, but here we are consider the smaller portion, that is the del C, it should be equal, the distance also small, so epsilon into A divided by del D. So the area means here all the sides are equal, so the length and breadth are both are equal, the del D into del D, so the area del D square it will come. So denominator already we have another one del D, so it may getting cancelled, the epsilon into D, that is the actual capacitance in the smaller portion. So we all know that is the work done, it should be equal C into V square, half C into V square. Here we are consider the smaller capacitance and the smaller portion, so the work done also small, so the del W it should be equal to 1 by 2 del C into del V square. We already found the work done V, W it should be equal 1 by 2 CV square, that is actual formula, but here we are consider the smaller portion, no, so it is the del W, that is the smaller work done and smaller capacitance and smaller potential difference. So the del W it should be equal 1 by 2 del C and del V square. Okay, so V it should be equal to E into D, that we know the relationship between the electric potential and the electric field intensity, but here we are consider the smaller portion, so the del V it should be equal E into del D. Del V it should be equal to E into del D. Actually V it should be equal to E into D, but here we are consider the smaller portion, that is why del V it should be equal to E into the distance, that is also small, that is the del D. So we can substitute the dV value as well as del V value as well as del C value in the expression. So the del W becomes, del W it should be equal 1 by 2 epsilon into del D, that we are already obtained here. So epsilon into del D. Then here similarly the V square, thus the del V we founded here E into del D. So E into del D whole square, because here the square is present. So we can make it square. So the del D, then del D square, del D cube it will come, then E square 1 by 2 epsilon into E square into del D cube. Okay, the del D cube we can consider and the del V. So the del V in the sense here the volume. Okay, it is not potential, it is the volume. The volume in the sense you have to multiply all the sides, length, breadth as well as height. Here it is we are consider we are cube, right? Here we are consider the cube, all the side, it means the length, breadth and height all are equal. So the del D cube we can consider as the volume. Okay, that is the V is the difference. Here V is the potential, but here the V is the volume, that is why I written here. Okay, so we can instead of the del D cube we can replace the del V, that is the differential volume. So we can move in RHS side to LHS side, del W by del V, that is the actual energy density. Okay, work done per the volume. Okay, work done per the volume, that is the energy density that we obtained. So the remaining term we can write 1 by 2 epsilon into E square, 1 by 2 epsilon into E square. We know the relationship E into epsilon, we can write D. Okay, E into epsilon we can write D. So another one we can write like that. So the 1 by 2 D into E joules per meter cube, that is the energy density. You can write the remaining term joules per meter cube. Why meter cube it came? Because we are consider here the volume. The volume unit is meter cube. Okay, area unit is meter square. If you are consider the length in terms of meter or centimeter. Okay, the length here it is the multiplication of length, breadth and height. So that is why meter plus meter, meter into meter into meter. That is why the meter cube it will come. While you are finding the volume, that is the meter cube. That is the work done per unit, work done divided by the volume. That is the energy density that we obtained. Okay. If you have any doubt, you can ask. Okay, thank you.